All right, so graph this quadratic function. This is very related to that whole transformations idea. What would be the parent thing that I would graph before moving? I'm going to do 2x squared just because then I get the stretching right. Does that make sense? And if you make a table, you can do this mentally or you can write it down. If you plug in 0, you get out 0. And I'm plugging into this, by the way. If you plug in 1, you get out 2. Let's make sure I'm recording. Okay, good. If you plug in 2, you get out 8. So 0, 0, 1, 2, 2, 8. And also plugging in negatives is the same as plugging in positives because it's an even function. So there's the parent thinger. So is everyone okay with how I got that? Once you have this parent function, how should you shift it? Left or right? Right 3, down 4. Great. 1, 2, 3, 4, 5, 6, 1. 1, 2, 3, 4, 5, 6, 1. Do you guys understand what I was just doing there? I was counting how far it was from this point to this point. Okay, so there's your shifted function. So it says I want you to determine the significance of the constants. So what does the 2 in front tell you? So a stretch, S-T-R-E-T-C-H, vertically by 2. Okay. What does the 3 and the 4 tell you?
3 is right, 4 is down.
It tells you to go right 3 and down 4. This point 3 comma negative 4, that's a point called the vertex. All parabolas have, it is the highest or lowest point in the parabola. And what I want you to be able to do is look at this equation and very quickly tell me what the vertex is. And if you can just think mentally about what the transformation is, you can find it fast. This means you move right? And this part means you go down. So hence the vertex is 3 comma negative 4. Does that make sense? Okay. All right, how about this one? What would be the parent that you would graph? You can do it 2 ways. You want to do the 1/2? How about 1/2 x squared? What are some good numbers to plug into that function? Well, everybody loves 0, right? What's the next good number to plug in that works out nicely? 2. And first you square 2. 2 squared makes 4. Half of 4 is 2. And the next good number to plug in would be 4. So 4 squared, half of 16 is going to be 8. So 0, 0, 2, 2, 4, 8. Okay, so there's the parent function. And I guess I might want to draw the transformations in 2 steps just because it helps me. Or not. What's the negative going to do? Out in front. It's going to flip it. And once it's been flipped, it's going to move that way too, right? And up 5. So let's just start by moving this point. It goes backwards 2, up 5. And now when I graph the rest of the parabola, do I go up or do I go down? Down, yep. So down 2 over 2 from that first point. And then I think it's down 6 and over 2 to the next point. If I give you a grid, I expect you to put the dots in the right places. Does that make sense? Okay. So I understand that connecting the dots is hard, but at least show me you know where the dots are, right? How did I get those points? So I counted the shape stays the same. So the distance from this point to those points is up 2 over 2. So that's why and then I went down because of the whole negative. So I went down 2 over 2.
Okay.
Does that make sense?
Once you get the vertex,
then you know where it's going to be, and the constant the negative will determine, like, is it down versus is it up.
Oh, okay.
Does that make sense?
Yeah.
Mm-hmm. Great. Awesome. Okay, and where was the vertex for this point? What are the coordinates of it? -2, 5. And notice in this picture, the vertex is a maximum, a highest point, right? In the previous one, it was a minimum or a lowest point. Does that make sense? Okay. Alrighty. So one way to find a vertex form is to use this completing the square thing. It comes up again and again. All right? So most people are going to do this completing the square a little bit differently than we did in the previous chapter. So I'm going to show you that way as well and show you how the other way is the same, okay? So first of all, completing the square only works if you have a 1 in front of the x squared. Remember that? So I'm going to take these first two terms and I'm going to factor out the 2.
Why don't you factor out the 2?
Because you complete the square using just the x's, and that 4 just hangs out and gets dealt with later. You could think in the problems that we did in the past, we moved that 4 to the other side. Does that make sense? Does that ring a bell? We kind of just left it alone. So here's the other way we did it, versus we would have said, okay, take that f of x, take away 4, and you've got 2 parentheses x squared minus 4x. That's what you would have done with the other method. I'm just choosing to leave it there, but then you have to leave it alone. And now here is the clever thing. Instead of adding a number to both sides, what people do is they add a number, and then they take away a number to compensate. Let me show you what number so what number in the parentheses would you add? Plus 4. Okay, and you've got this plus 4 hanging out, so like going back to the way we usually did it. Now there's a couple of complicated things here. Because there was this 2 in front of the parentheses, what number have you actually added? 8. So if you added 8 to this side, you've got to add 8 to that side too, right? What does that 8 become if you move it over to this side? -8, right? Does that make sense? And people often skip that step and just write -8. Because what they've did, oh my God, that was so bad. What they've done then is they've added 8, right? And they've taken away 8. And that means effectively you've added 0 in a very clever way, but it hasn't changed the original equation. So you add something, but then you take it away to compensate. Does that idea make sense? It's going to be faster. And then you factor. This becomes 2 parentheses x minus 2 squared minus how much on the end? 4. And where is the vertex?
2 down 4.
Yep, over 2, down 4. I know this method is harder and it's weird to add and subtract a number. I totally get that. But the thing is, people are going to do it that way. You've got to get used to it. How you can check that you're right, if you're doing a quiz and you're in a timed situation, you can, or you have some spare time, you can take this thing and you can multiply it out. As long as you've done everything correctly, what should you get? You should get the original thing. Does that make sense? So if you take this thing and multiply it together, it should equal this thing. Does that idea make sense? Okay. So that's how you would check and make sure that you were okay. All right, let's try another one. Okay, so same idea. Take the greatest common factor out of the terms that have x's. What is that? 3. X squared minus, is that 6x? Leave the space. Okay, and what are we going to add in that space? 9. Very good. And so what number have we effectively added? 27. And so since we've added 27, we must compensate by taking away 27. So that's 3 times x minus 3, the quantity squared, minus 25. Notice I'm not making you graph that. Where's the vertex? 3, negative 25. If you did have to graph it, you'd shift your parabola right 3 down 25, and that's where the vertex is. That vertex often is the most important point, so it's really important to be able to find that. Okay?
You always subtract, like that 9 times 3.
You always do the opposite, okay? Because sometimes we'll have a couple examples where this number is a negative number, in which case you'd actually add something. Okay. So the 2 examples we did, you always subtract because you have added something and you must do the opposite so that you've added nothing. Okay. So that's the tricky part. Like, see, this one's a negative. All right, so here, let's start. We'll do the same process. What comes out of those first 2 terms? If you want to make that into a 1, you've got to take out the negative 1/2. Does that make sense? So that becomes negative 1/2, parenthesis, x squared. What does taking out the negative do to that second negative sign? Makes it positive. And then 1/2 times what number is going to make 1? 2. And I've got that plus 2 hanging out on the end, right? Does that make sense? And you could check at this step. You could say, okay, I'm not sure if I'm right, but if I distribute that negative 1/2, I should get back what I had. Negative 1/2 times x squared is negative 0.5 x squared. Negative 1/2 times 2x is negative 1x. So you know you've done nothing wrong. All right, now what number do we add inside those parentheses? 1. Because of the negative 1/2 in front, what have you actually added? You've actually added negative 1/2. Because if you were to distribute this, negative 1/2, right? The thing you've added to the equation actually is negative 1/2. So how do you compensate so you've added nothing? You add a positive 1/2 here. Do the opposite. So that's negative 1/2 x plus 1 squared plus 2.5, right? I'm going to skip the graphing of it because we already graphed a 1/2 x squared today, and I don't make sure I get through the whole lesson. Just tell me where the vertex is going to be. 2.5. And will it be right side up or upside down? Upside down. Does that make sense? It's a sad parabola because it's negative x squared. Okay, let's try another. This is by far the most common way. Like, this is the way that my Calculus 2 students have seen it recently. So you only can complete the square when the leading coefficient is 1, so you have to take out that negative. X squared. So what does my 4x become then? Minus 4x. And you have that plus 2 hanging out on the end, waiting to be dealt with. So what number do you add in the parentheses? 4. 2 squared, right? Okay, and what number have you actually added because of the negative? So you've got to compensate by adding positive 4. You could actually check at that stage that you were at by just distributing the negative and seeing if the stuff cancels out to what you had in the beginning. So that becomes negative, parenthesis, x minus 2, whole thing squared, right? Plus how much on the end? 6. So your vertex is 2, 6, right? Let's graph this one. Do you remember the basic pattern for the points in a regular parabola? Regular parabola goes through 0, 0, 1, 1, 2, 4, right? That's like the basic parental parabola pattern. Does that make sense? Okay, so shift that over to the right 2, up 6, and then just make it upside down. 1, 2, 3, 4. There we go. So pretty. Are we going to do the other? Oh my gosh. I should read. I never read my directions. This is terrible. Let's do it just for this one. So give the maximum or minimum value, the domain, the range, intervals of where f is increasing or decreasing. Okay, so does this function have a max or a min? At the point 2, 6. There is no minimum. Okay. How about the domain? There is infinity can't, it would be negative infinity, and that can't be a minimum. So if something goes off to infinity, there just isn't one at all. That's a good question. Okay, how about the domain? Are there any numbers you can't plug into a parabola? No, so that means the domain is all real numbers. We'll use the R symbol to save time. How about the range? Negative infinity to 6, and you have a bracket. Okay, and then increasing and decreasing. And the more I thought about it, the more that I am convinced that your book did this a little bit wrong. So the point where you change should not be included. So this function increases from minus infinity to 6, but not including 6. And it decreases from 6 to infinity. I'd say one good reason that you can't include that is that you'd be increasing and decreasing at 6 at the same time, right?
Would it be increasing to 2?
Yes.
Oh, shoesnnits. Yes, it is to 2. So sorry. You're right. I was just checking that you guys were all here and awake. Yep. Increases up until x equals 2, decreases after 2. I was so convinced I need to tell you, but you don't need to put a bracket around that. But I think your book does. I think that they're wrong. Okay, that book. Everyone's allowed typos. Okay. Have you guys ever seen this formula? Since that vertex is so important, there is a standard formula used to find it. Now you can prove that this is the formula using completing the square. It's just really tedious. Once you know calculus, you can prove this in 3 lines. It's really fast. You use something called the derivative. You could do that for fun, for the derivative is equal to 0. So the point is that what this formula tells you is the x-coordinate of the vertex. And then if you want to find the y-coordinate, how'd you figure it out? Just plug it in. And notice that there is like a little negative sign that's hiding there, right? So this tells you that x equals negative b over 2a. The c-coordinate, this c thing on the end, doesn't affect the x location of the vertex. When you plug it in, it'll affect the y location of the vertex. Okay? All right, so let's use that to find some vertices. Okay, so use the vertex formula to find the vertex. And also, that's called the axis of symmetry. So the axis of symmetry is the line that divides the parabola in half, so that it like divides it in 1/2 on one side, 1/2 on the other side. Okay. So x equals negative b over 2a. So what goes in for b from your equation? So negative 6 over 2 times 1. So x equals 3. And the y will equal f of 3, as in what you get when you plug in 3. So what do you get when you plug in 3? I got 9. I've got to confirm. 9 minus 18 plus 4. So negative 9 plus 4. Is she right? Negative 5. So the vertex is at 3, negative 5. So I said we should confirm by completing the square. So let's just check that we're right. Do I have to do any kind of weird factoring out stuff with this one? No, because it's just plain old x squared. And honestly, the ones you see most often in calc classes are pretty simple ones like this, where you just have plain old x squared. What number do you add to the x squared minus 6x to complete the square? 9. And you compensate by? Subtract 9. So that makes x minus 3 squared minus 5. Does that agree with the location of that vertex? Yep. Forwards 3, down 5, right? Okay. Great. Alrighty.
The axis and symmetry?
Oh, the axis of symmetry. Axis of sim. Sometimes I abbreviate that AOS, just FYI, okay? That might not be uniform, it's just me trying to be like faster. It is the vertical line x equals 3. The axis of symmetry always goes through the vertex. Does that make sense? If you were to graph this thing, you'd go over 3, down 5, and then you'd have that kind of shape, right? Does that make sense? So the axis of symmetry will always be the thing that divides it in half. And because the parabola is kind of like the halfway point, it's always going to go through, the vertex is always the halfway point, it's always going to go through the vertex. So once you've found the x-coordinate of the vertex, you've also found the axis of symmetry. Okay, awesome. What? Did I have a slide twice?
Yeah.
I'm so confused. Ready? So we had the function was f of x equals what? X minus 3 squared minus 5, is that right? So it's a regular parabola shifted how? Right 3 and down 5, exactly. 1, 2, 3, 1, 2, 3, 4, 5. Okay. Ooh. All right. Okay, so does this function have a maximum?
No.
Nope, none. Does it have a minimum?
-5.
So let's give the location 3, -5, although -5 actually is the value of the minimum. The domain, the range, lowest value, and you actually hit it, so square bracket up to infinity, increasing, decreasing. So at which x value does this function start increasing? At 3, and goes on increasing to all infinity and beyond. And it decreases from 2, 3. Perfect. Whew, read my directions. Okay. So this next thing says to get an equation of a parabola that has this vertex and has this y-intercept. So first, I think it'd be useful to translate that y-intercept into an ordered pair. Does that make sense? So if your y-intercept is 2, what is that as an x comma y? 0, 2. Very good. Okay. Now, does it make sense? All parabolas can be written like this. Y equals a x minus h squared plus k. It uses the same letters as circles, actually, and there's a reason for that. Probably won't talk about in this class. And the reason that this uses minus h is then you know that h is the x-coordinate of the vertex, because you'd go over h, up or down k. That's the reason. So you know the vertex is 4, -2. So you can plug that information in, right? So you got y, and that's a special xy, as Nick goes in for hk. So hk, in this case, is the vertex. So you've got a x minus 4 squared minus 2. You know those numbers go there because that's your vertex. And you could think, okay, yeah, I've gone over 4, down 2. If your y-intercept is 2, you got to have a happy parabola, right? So how can you use that 0, 2 information to figure out more information about the parabola? Plug it in for x and y, exactly. So it's a random xy, right? So 2 equals a, 0 minus 4 squared minus 2. And then solve for that a. That a in front tells you if the parabola's been stretched or shrunk or just stayed the standard size. So add the 2 to the 2 and you get 4 equals a times what number? 16, awesome. So is a 16 fourths or 4 sixteenths? 4 sixteenths, or 1/4. So your equation is 1/4 x minus 4 squared minus 2. So one thing that does involve knowing is you kind of have to know what a general parabola equation is. And if you'd written that as plus h instead of minus h, you put in minus 4 for the vertex thing because of the whole oppositeness happening with the direction of the moving stuff. Does that make sense? Okay, so it is possible to bend it. Now, the most common example of using this vertex formula in classes is to find maximums and minimums of functions that actually mean something. So today we're going to pretend you're a dairy farmer and you want to build a fenced-in area. So you have a barn. It's 150 feet long and 75 feet wide, and you have 240 feet of fencing, and you want to use it all to construct 2 identical adjacent outdoor pens with part of the long side of the barn as one side of the pens. You can avoid using fencing there. Does that make sense? And the question you have is, how are you going to enclose the most area so you can fit the most cows? So the first thing we're going to do is come up with an equation that tells you the area of the pen as a function of x, because it actually depends on, and then in this case, x is the, did I define x? I'll draw a picture. I'll show you what x is going to mean. So there's your barn. It's not drawn to scale. We're just going to pretend. And you're going to make 2 pens like this. And they're going to be evenly sized. And just to make it easier, I'm going to call this side x. Does that make sense? So I got that side is x, and that side is x. How many feet of fencing did I buy from Alaska Feed? 240. So if I've used up x, x, and x on those perpendicular sides, what's left for the other side? 240 minus 3x. Beautiful. Okay, that is the picture. It really helps these problems to draw a picture. If you know nothing else, draw a picture. Makes you feel better.
Why is it minus 3x?
Because you had 240 total, and you used up x, x, x. And so if x were 10, you'd have 210 left, right? Does that make sense? Okay. So I want a mathematical model that tells me the area. So using this picture, how would you find the area? It's a rectangle, right? 240 minus 3x times x. Or I'm going to write that as negative 3x squared plus 240x. So that's the mathematical model.
Isn't the barn like 150 feet long?
Yes, which means that you do have some restrictions on the sizes that you have. As in that side that's 240 minus 3x has to be less than 150. And if it's not, then you have to kind of like say you're outside the domain. So there are some like physical constraints on the problem. Yes. Yeah. So my possibility of like 10, 10, 10 wouldn't work, right? What's up?
Is the x on the outside because it's like base times height?
Yeah, it's a rectangle. Yeah, exactly. Mm-hmm. Okay. So now think about this parabola. Is it happy or is it sad? It's a sad parabola. It has a maximum. Does that make sense? This is a parabola that tells you all of the different areas given a specific x. And this thing, that x, is the one that is the best. It is the biggest. So to find the best way to do this, you find the vertex. That's what this does. So find the value of x that produces the maximum combined area. So you take your equation, that was a of x equals, was it negative 3x squared plus 240x, right? Find the vertex. And it always helps me to think, okay, that's a sad parabola. It has a maximum. So the vertex will be negative b over 2a, or negative 240 over 2 times negative 3. So that's negative 240 over negative 6, which will be 40. And so back to your picture. This is 40, this is 40, and this is 40, right? How much does that leave for the rest of the fencing? And does that fall within the fact that our barn will... Yeah, it does. Okay. So there we go. X is 40. That's the perpendicular to the barn. And then the other side is 120. And that's why how you make the biggest possible area. One thing you'll do in calculus is solve problems that aren't parabolas, like this, where you're finding the biggest point or lowest point. There's a technique called a derivative that lets you do that. But for the parabolas, you can use algebra 2/pre-calculus. Yeah?
So for C, it says find the dimensions in the area. Do we just have to find the actual area now that we have them now?
Yeah, exactly. You got them now, exactly. So find the dimensions of the pen. Well, it's 40 by 120. And it is important to say, 40 is perpendicular to the barn because it isn't the other direction. Does that make sense? You couldn't have those sides in the middle being 120 or you wouldn't have enough fencing for it. And so what is the area, total area? For a, okay. But they do say of 1 pen. So divide by 2, yep. So watch out for the wording on those questions because you can be right but just not answer the exact question that you're supposed to. Does that make sense? Just read kind of carefully. Did you guys know about example 7? Did you know that your cars get better gas mileage? There's a speed at which you get the best gas mileage. It's approximately 50-some miles per hour. So back when gas was super expensive, my dad had a car that told you what your gas mileage was, and I would drive it at the point that would get the maximum gas mileage, which meant I got places more slowly, but I saved money. So that's I'm a nerd. Okay, whatever. So this equation for x is between 30 and 65. And of course, this is different for different cars. Like, a Toyota Prius these days, because it charges when you're going at low speeds and you're stopping and starting, has a different equation that's special, okay? So for some specific car, this tells the average miles per gallon based on the speed. I don't know what sleed is. Sounds like a Doctor Who word. Based on the speed driven. So you want to figure out what speed should you drive to get the best gas mileage because you want to be cheap. So think about it. Is this parabola? This is a parabola, right? Is it a happy parabola or a sad parabola? It's a sad parabola. So it has a maximum, right? So you can find the maximum using that vertex formula. So it will be x equals negative b over 2a. So negative 2.54 over 2 times negative 0.25. Oh, 0, missed a 0 there. 0.25. So that's negative 2.54 over negative 0.05. And obviously for stuff like that, I'd give you a calculator, but I got this is 50.8. Do you know that back in the 70s when there was an oil crisis, they actually reduced the speed limits for this reason? Like that was why they did it. Why speed limits are set at 55 is because it's close to what the optimal gas mileage speed is, and it was used to conserve gas. So that's the reason speed limits are what they are in some places. Okay, and then the next question. So this equation, when you plug it in x, tells me how many miles per gallon you're going to get. So this tells you how fast you'd be going, but to figure out what your MPG was, you've got to actually plug that number in. Does that make sense? Okay, so the next question is, so this compact car has a 14-gallon gas tank. How much farther are you going to be able to drive? So how many more miles are you going to get comparing this speed with the previous speed? Okay, so what we can figure out the miles per gallon for going 50.8 miles per hour. So find m of 50.8, as in plug that number in, negative 0.025 times 50.8 squared, 2.54 times 50.8 minus 30.
Is it 2.54?
Yeah, 'cause I'm plugging the 50.8 into this equation.
Oh.
Yep, it is 2.54. And given a calculator, you could do that, right? When you do that, you get 34.516, that's your miles per gallon. How would you figure out your miles per gallon at 65 miles per hour? Plug it in. So negative 0.025 times 65 squared, 2.54 times 65 minus 30. And once you calculator, you get 29.475 miles per gallon. It's like, what, 5 mpg different, isn't it? Okay. So how would you figure out how far you can go on a 14-gallon gas tank, given your gas mileage? So we'll say 14 gallons at 50.8 miles per hour, you go 34.516 times 14, which is equal to 483.2 miles. The labels also cancel, right? Miles per gallon is miles over gallon, right? Times how many gallons makes miles, right? So that's miles over gallons times gallons makes miles. How about 14 gallons at 65? You go 29.475 per gallon times 14 of them, and that makes 412.625 miles. So approximately, what is the difference? How would you figure it out? You just subtract the 2 and it's 70.6. Which means if you're going someplace like Anchorage and you don't get gas in Healy or Fairbanks and you find yourself in a pickle, slow down. Does that make sense? Okay. Awesome. Now the last thing, I'm not sure if we can finish it all the way, but we'll try, is solving inequalities. And this won't be very hard. We're going to solve them by graphing. So we're looking for where is this x squared minus 5x bigger than or equal to negative 6. Solving inequalities with linear functions is easy. Quadratics and different stuff is hard. Okay, like things, once you don't have a line anymore, you can't solve it the same way you solve a regular equation, because in this case you might have a negative times a negative, which makes a positive and flips stuff around. Okay, so I think the best way to solve this stuff is using a picture. So take this and instead translate it into x squared minus 5x plus 6 is bigger than or equal to 0. Does that make sense? Yeah? Okay. And then bigger than 0 means positive, right? What you're going to do is you're going to look for where x squared minus 5x plus 6 is equal to y is above the x-axis. Being above the x-axis means your y's are positive, right? Below means they're negative. Does that make sense? So make a picture and see where it's above the x-axis. Now, the points at which it crosses the x-axis, those are the x-intercepts, right? So here's another way to graph this. Find the x-intercepts. So find x-intercepts. Here I'm avoiding completing the square because that 5 is odd. 5 over 2 makes a fraction, and I don't want to have to deal with fractions. So set y equal to 0. 0 equals x squared minus 5x plus 6. Does that factor? 2 and 3, yep. So where does this graph hit the x-axis? X equals 3 and 2. So over 3 over 2, and is it a happy or a sad parabola? Happy. So it looks something like that. You don't care exactly what it looks like for this question, it just looks something like that. So you're looking for, when is this parabola bigger than or equal to 0? So that happens from here to here, including the place where it equals 0, right? And then from there to there. Does that make sense? So give me the x's for which that is true. And a square bracket at 2, right? And then union 3 to infinity. Exactly. What if the inequality had not had the or equal to on it? What would change? You wouldn't include 2 and you wouldn't include 3. Does that make sense? There'd be open brackets. What if it had gone the other direction, but if, as that was an if. So if it had said x squared minus 5x plus 6 is bigger than 0, then equal to 0 isn't part of what you were looking for.
Oh, the 2 and 3 are on.
Exactly, or 3 aren't equal. What if I'd made it x squared minus 5x plus 6 is less than or equal to 0? It'd be that little tiny bit between 2 and 3, and that's the part that would satisfy inequality, okay? So when you're solving these kinds of inequalities, make the equation somehow related to 0. That's the easiest thing to tell. And then from there, graph it, and you can be a rough graph and be perfect. I won't grade those graphs, because the purpose of those graphs is to figure out where is that function positive or negative. Okay? Let's do another one. did something funky here. Just let me think to move stuff around. All right, so x squared minus 4x plus 14 bigger than or equal to 0. Oh, that's wrong. That should be minus 14. Yes, it should. Thanks. Okay. So is that one where we could solve it equal to 0 really, really easily? I don't think it factors, does it?
No.
So then to make the picture, it doesn't.
Does.
No, it doesn't.
Is that just fact? That's
Yeah, you did it wrong. Sorry. What'd you factor it into? X minus 7, x plus 2, that adds something different. Not 4.
never mind. I got 6 plus 3 instead.
Okay, awesome.
I'm tired.
Happens. So if you can't factor, how would you graph? Complete the square. So it'd be x squared minus 4x, and what do you add? Minus 14 plus 4. X minus 2 squared minus 10 bigger than or equal to 0. Whole. Minus 18. Oh, holy moly. So you're going to go over 2, down way too far for me to know exactly where those points of intersection are. Well, crapola. Even so, they're not going to be nice whole numbers because that thing doesn't factor. So how would you figure out where x squared minus 4x minus 14 equals 0? What would you do to figure that out? You could find the x's using either, from the last chapter, completing the square or the quadratic formula. Does that make sense? Let's complete the square and we'll stop on this one. So x squared minus 4x would equal 14. Now we add 4, right? X minus 2 squared equals 18. X minus 2 equals plus or minus root 18, right? Does that make sense? It's a little speedy. X equals 2 plus or minus. Can you simplify root 18 at all? 2 and 9, so it'd become, there you go. Okay. So this point over here, whatever it is, will be 2 minus 3 root 2, right? What's that point over there going to be? What's the other one? 2 plus 3 root 2.
Also, it's supposed to be kind of like...
Yeah. You could get a decimal and approximate where they were exactly. Or does that make sense? So there's some weird spot. But the graph tells you, like, is it a happy or sad parabola? You could also skip the completing the square and just go straight to the solving. What would your intervals be? Where is this thing positive? Square bracket, union.
2 plus 3, right?
Infinity. All right, thanks. Let's check for a second.